everyone. For today's lesson, we are going to continue our discussion on algebraic properties and proofs. Make sure that before you watch this video lesson, you have completed our video lesson over the algebraic properties and proofs. So this is going to be about all of the different properties that we are going to use whenever we conduct an algebraic proof to solve an equation. So you'll want to make sure that you have watched this video prior to completing these examples. So in the video lesson, I showed you guys how to write a two-column proof where we write a reason for each statement. And our reasons, once again, are going to be all of our properties of our algebraic properties of equality. We had the addition property, subtraction, multiplication, and division property that says whatever you do to one side, you have to do to the other, whether it's add, subtract, multiply, or divide. We also had the properties of substitution, which means that you do like a replacement. We have a equals b, y equals a plus 7. That's the same as y equals b plus 7 if a and b are the same thing. We also have the distributive property of equality that says that if you have a number on the outside of a set of parentheses, you can distribute that number by multiplying it to each term inside, and you'll end up with an equivalent statement. Finally, if you ever have to combine like terms where you would simplify the problem, we would either write the word simplify or CLT to come up with a more simplified answer. Whenever you write a two-column proof, you're always going to have one side that's going to represent your statements and your reasons. You will also need to make sure that you write down the original equation that's given to you, and your reason for why you write that down is because it's given. Another structure piece is that all of your statements need to be numbered. And that's an organizational component that will help us to identify why we wrote down the line or the statement that we did. Let's go ahead and look at this example. We want to solve 2x plus 3 equals to 9 minus x using a two-column proof. So we're going to draw out that two-column proof where you have one side that's dedicated to statements, and the other side is dedicated to reasons. Statement number 1 is always what's given to you. We have 2x plus 3 equals 9 minus x. Now, your answers might be a little bit different than maybe my answers or the answers in a book or answers in homework. As long as it's founded in logic, that is okay because everyone solves these problems differently. But you must show every single step in everything that you do. So what I want to do first, which I'm writing my first statement reason is given, I want to bring this x to the other side because I like to have my leading coefficients be positive. So I'm going to start off by adding x to both sides, and I'm just writing it down very tiny because that's not a step. That's not a statement. A statement is 3x plus 3 equals 9. That is a statement. So that's the part that needs to be big. Why did I write this? Well, I wrote it because what I did to both sides is I added x to both sides, and I used the addition property of equality. Next, I need to bring 3 to the other side, so I'm going to subtract 3 on both sides, and my next statement is going to be 3x equals 6. That's the piece that needs to be big. And what I did to both sides is I subtracted 3 on both sides, and that's the subtraction property of equality. Next, I need to get x alone, and I'm going to divide both sides by 3. So my next statement is x equals 2. And the reason why I wrote it is because I used the division property of equality. Once you know what x is equal to, you are done. Hopefully you found that to be not that bad. All we're doing is justifying every single step when solving an equation. Let's go ahead and move on to the next example. In this example, we want to solve 2x plus 4y equals 16 for y. What this means is we need to get y alone. And we're going to turn this into y equals mx plus b. That's what we want to do. Turn this into y equals mx plus b form, where we are going to write a reason for each step. Let's use our 2-column proof, and let's set this up just like we did before. Here is our statements, and here are our reasons. My first statement is what is given to me. That's 2x plus 4y is equal to 16. And we write that because it is given. Now, my goal is to get y alone. So I need to get, and I want it to be in mx plus b form. So I need to bring that 2x, that whole term of 2x, to the other side. And I'm going to do that by subtracting 2x on both sides. So my next step is going to be 4y is equal to negative 2x plus 16. And what I did here is I used the subtraction property of equality because I subtracted 2x on both sides. Next, I need to get y alone. So that means I need to get rid of 4 times y. I need to get rid of the 4. So that would indicate that I would need to divide every single term on one side and every single term on the other side by 4. That will give me my statement of y equals negative 1/2 x, because 2 over 4 is 1/2. X plus 16 over 4 is 4. And what I did here is I used the division property of equality. And now that I have y alone and it's in that mx plus b form, I am done. There's nothing more to show. So being comfortable with working with properties is something that I need you guys to feel comfortable working with, because we are going to be using these properties a lot. So being able to recognize and complete statements using these properties is very important. Other properties outside of the algebraic properties that we had were the reflexive property and the transitive property of equality. The reflexive property says that numbers are equal to itself, segment lengths are equal to itself, and angle measures are equal to itself. Making sure that you're using appropriate symbols. There's going to be no line above if we're talking about segment length and equality. And there's going to be the little m that's in front of each angle if we're talking about angle measures. Numbers, of course, are always equal to themselves. That is the reflexive property of equality. The transitive property of equality, which is like the triangle property, that means that you're given 2 pieces of information and then you connect those 2 statements together to come up with a new statement. So like if 2 plus 2 equals 4 and 4 equals 4 times 1, we can say that 2 plus 2 equals 4 times 1 because they're both equal to 4. And that would be your final conclusion. With segment length, if AB's length is the same as CD and CD's length is the same as EF, you can conclude that AB and EF also have to have the same measure. So it's forming like a triangle relationship. Same thing with measures of angles. If angle A is, or measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A has to equal the measure of angle C. They're all connected. So let's go ahead and look at this one. If R is equal to S and S is equal to 44, then R has to equal 44 because R and S are the same. Using the reflexive property of equality, the measure of angle N has to equal the measure of angle N. Reflexive means looking at like a reflection in the mirror. It is equal to itself. The addition property of equality says if RS equals TV, then that means that RS, segment RS plus XY, equals segment TV plus the segment xy. We are adding xy to each side of the equation. And finally, the substitution property of equality, which is our replacement property, says if the measure of angle 1 equals 20 degrees, and the measure of angle 1 plus the measure of angle 2 equals 75 degrees, I see the measure of angle 1 written twice. I can replace the measure of angle 1 with 20 degrees. I can say 20 degrees plus the measure of angle 2 has to equal 75 degrees. This is the replacement or substitution property of equality. And that is the end of today's lesson. If you have any questions over anything that I talked about in this lesson, please feel free to email me. Otherwise, I hope you have a wonderful day.